Hello, everybody. Derek Demeter with the Emil Buehler Planetarium at Seminole State College. I have Justin Cirillo here too, our planetarium specialist, and we also have a special guest. His name is Ken Brandt. He's with a planetarium up in North Carolina. He'll tell you more about it a little bit later on. But unfortunately, we're unable to do a Facebook Live session right now. The reason why, unfortunately, is that there must be an issue between Zoom and Facebook. So unfortunately, we are going to have to do this a little bit different. What we're doing is we're actually recording this session for tonight, and hopefully you'll be able to get a chance to watch it at a later time. But either way, we are determined to get you a really cool experience tonight. And so what we're going to do here is, as you can see, I'm also linked in here because I'm using another laptop that utilizes some of our planetarium software. So I'm kind of cloning myself here tonight. So now, of course, the one feature we don't have available right now because we are not live is the fact that you all won't be able to comment with some questions, but that's okay. Hopefully, if you can, on YouTube. We'll also be posting this on Facebook as well. The link to it, you can go ahead and leave comments in the questions below, or in the comments below, and we can do our best to answer those questions for you during that time. So I hope that you enjoy this session. Regardless, we are going to Mars. Yes, we're going to Mars. We are taking a trip to the red planet Mars tonight. And we have a lot of really cool things we're going to explore tonight. And so what we're going to do is we're going to go ahead and start off with a little bit of a tour of the red planet Mars. Before we do that, I want to go ahead and introduce to our guest here, Ken, talk a little bit about himself and maybe a little bit about his planetarium. So Ken, go ahead and take it away.
Good evening, or whatever time you're watching this. I direct the Robinson Planetarium in Lumberton, North Carolina. It's a small public school-centered planetarium. We serve about 9,000 students a year, give or take. And I'm also a JPL NASA Solar System Ambassador, which means I have access to all kinds of cool information and stuff about Mars, which of course you will hear about later during the program. So I'm done.
All right, well, thank you, Ken. Thank you very much. We have some users messaging me here saying, what's going on? So just wanted to let them know about what's going on. But anyways, great. Well, we really appreciate you, Ken, for being here tonight and to join us for this. I think it's really fun to be able to collaborate with some of our planetarium friends. Mm-hmm. And Ken, you're gonna have a really interesting perspective about Mars. You're a big Mars guy. I always see you with your Occupy Mars hat and shirt and all that. And Justin's going to be talking later on this evening about human exploration on Mars. And he's going to tell you all about our kind of progress and what we plan to do and how you can find out about latest information in regards to going to Mars. I'm sure a lot of you are probably interested to maybe going to Mars yourself or maybe working on the potential projects in the future to go to Mars. So, all right, so what I'm gonna do here is I'm gonna go ahead and again, I have my computer here set up. What we're gonna do is I'm gonna go ahead and share. Actually, what I need to do real quick is I need to make all of you co-hosts, yes. In order to do that, we can, so that way we can officially get this going here. All right, so what I'm going to do now is I'm going to go ahead and start sharing my screen here. All right, so everybody see that? There it is. So we're using a software called UniView. We use this in the planetarium for our shows. So in many ways, this is very similar to what you will experience if you were to come to the planetarium. So anyway, so here we have the planet Earth right there, our home planet. This is where we live. This is basically where we've been for the past you know, many millions of years in our human evolution. But what we're going to do here is we're going to go ahead and take ourselves to the planet Mars. And we can't just shoot ourselves to Mars in a straight line the way we see in shows like movies like Star Wars and things like that. But what we can do, though, is we can look a little bit about the physics of how it works. And Ken has a really cool video that we're going to share with you all that talks a little bit more about the science behind going to Mars. So what we're going to do here is we're going to go ahead and zoom out, and we're going to go ahead and take a look at our orbit. So Earth obviously is closer to the sun than Mars is. Actually, Mars is almost double the distance. So it takes a lot longer for Mars to go around the sun. A year on Mars is actually 2 of our years about. So imagine trying to create a calendar for that. So right now our date is actually set for July 17th. And if you happen to know the answer to that question, maybe you can leave a comment when you watch the video here. You know the answer, but don't worry, we're going to give it away anyways. Basically, we're going to have to launch at a time when the Earth catches up to the red planet Mars. So you can see here, there's Earth's orbit right there, and right over here is Mars's orbit. And what we have to do is when we launch an object towards Mars, we're going to have to launch it in a way that essentially Earth is traveling faster than Mars is. So over time, Earth is actually going to catch up to the orbit of Mars. So our distance between each other is at its shortest. We call that opposition. And what happens is that when we launch a rocket to Mars at this point, a little bit ahead of time, eventually we're able to get to Mars on the way. So we call this a slingshot. We're going to have to slingshot our way out using gravity assists and eventually be picked up by the orbit of Mars or the planet Mars itself. And that's really the best way of going. And even at that, the trip there is about 9 months. So this is not like going to the moon, which only took a few days. This is going to be quite a long journey. But what I'm going to do here is I'm going to go ahead and let Ken share a really cool video with all of you, kind of showing a little bit of the science behind traveling to Mars.
First, you'll need a fast rocket to escape the pull of Earth's gravity. The heavier your spacecraft, the more powerful your rocket needs to be to lift off. Next, make sure you launch at the right time. Mars and Earth orbit the sun at different speeds and distances. Sometimes they're really far apart, and other times they come closer together. About every 2 years, the 2 planets are in perfect positions to get to Mars with the least amount of rocket fuel. That's important. The total trip is over 300 million miles. Finally, make sure your aim is right. You can't shoot for where Mars is at launch time. You have to aim for where it will be when you get there. It's a lot like how a quarterback passes a football. Also, you may need a few thrusts to correct your direction along the way so you don't miss Mars. If all goes well, you'll get to the red planet in about 7 or 8 months. Then, if you actually want to land on Mars, well, that's a whole other challenge.
Courtesy of the Jet Propulsion Lab. One of the things I really like about this video is that it shows Earth and Mars rotating and revolving around the sun at the same time. And you almost never see that in animations. So it's really cool. So there's the video.
Thank you, Ken. Thank you. Yeah, that's a really cool video kind of demonstrating the science behind how we travel to Mars. And so what I'm going to do now is I'm going to go ahead and continue sharing the our UniView space here. And what we're going to do now is we're going to go ahead and actually travel to the red planet Mars. Are you all ready for this? All right.
Let's go.
Okay. All right. Good. Good. I was like, I'm not hearing a lot of excitement going on there. But yeah, let's go ahead and fly to the planet Mars. So here we go. Now we're going to kind of cheat a little bit in our venture to the planet Mars here, but we're going to go ahead and now fall into the orbit of Mars. And as I said before, a year on Mars is twice our years on planet Earth. About 24 months is 1 year on the planet Mars. But you know, interesting though is a day on Mars is pretty much the same length of a day on Earth, about 24 hours. So even though we have twice amount of years on Mars for our year, we have pretty much almost the same type of day. So pretty interesting to think about that. So here we are. Welcome everybody to the red planet Mars. And one of the things I want to show you all is a little bit about some of the different features you see here. This is a large borealis basin here. This is a very large basin, which we think at one time could have been covered with water. And then there's also several other features on Mars that I want to share with you in a little bit. But let me talk about a little bit of history of Mars. Mars wasn't always barren like it is today. If you look at the surface of Mars, you can see that it's covered in this red dust, which is mostly iron oxide, and that's what gives its color. So the ancient people, when they saw Mars in the sky, they saw that this was this bright red star in the sky, and they attributed that to war. A lot of cultures around the world attributed Mars to something dealing with warfare because of the color of it. But of course, we know today the color of Mars is due to the oxidation or iron oxide found in the dust and soil on the planet Mars. But there's actually a lot more to Mars than just iron and dust and rust and stuff like that. There's actually a lot of minerals that are very similar that we find on Earth. We find silicas, we find feldspars, we find other metals. And we find actually a lot of water on Mars. Believe it or not, there is still a lot of water, but it's not liquid water like we find on Earth. It's frozen water. Pretty much all the water on Mars is frozen. There are small little areas where we do actually have little tiny kind of briny, silty, wet soil that has a little bit of water. But back a long time ago when the planets were forming and everything was cooling down, Mars actually was a lot different than it is today. Believe it or not, we think that Mars actually had water. Yeah, believe it or not, it had water. And what I'm going to do here is I'm going to stop the share real quick, and I'm going to go ahead and bring up a little couple presentations here. Let me do that. Here we go. Sorry, I'm trying to control two things at once here. So let me go here and share my screen. All right, so we can see here that, oops, here we go. Oh, I guess it's finally working. All right. This right here is the red planet Mars as we think it was billions and billions of years ago. So we thought at one time that Mars actually very possibly had water to it. Similar to Earth, it had an atmosphere of oxygen and carbon dioxide and other gases that could have been very similar to Earth. We had water vapor clouds. So Mars could have very likely, might have, possibly started some form of life. We don't really know that for sure. The only way we can know if there's life that once existed on Mars, we have to go there. We have to take soil samples. We have to look for trace fossils and other things that could potentially show evidence of life at some point. But we do know that Mars had evidence of liquid water on the surface. We find rivers and we find erosion. We find all these things. And Ken will talk a little bit about that when we talk about some of the robotic missions we've sent to Mars. So a long time ago, Mars was actually much different than it is today. It was a wetter, hotter planet. And the reason we think what happened to Mars is that Mars actually had a fairly hot core. And over time, though, the mass of Mars, the size of Mars, it started to cool down and lock together and basically lose its magnetic fields. Just so Earth has a magnetic field, and our magnetic field churns around, our core churns around and generates that magnetic field. And unfortunately, Mars lost its magnetic field. But there's a spacecraft that's currently orbiting Mars today, and that spacecraft is called MAVEN. And MAVEN is actually exploring the atmosphere of Mars and why Mars has such a thin atmosphere today. Mars has a very, very, very thin atmosphere, very little atmosphere at all. And it's just a little trace amount of carbon dioxide and some other gases as well, but it's mostly carbon dioxide. But what is happening to Mars? Well, when MAVEN as MAVEN was heading towards Mars, it noticed that it was able to look at other wavelengths of light. And what it noticed is that there was a lot of different gases and different molecules that were surrounding the red planet Mars, almost as if the atmosphere has been blowing off over the course of these billions of years. Now, what could potentially be blowing off and shedding off the atmosphere of Mars? Well, it's the sun. See, the Earth is protected by a magnetic field which shields us from this constant bombardment, what we call the solar wind. It's this constant stream of solar particles that react with our atmosphere. Sometimes some of those particles get trapped in our magnetic field and they generate auroras, the northern and southern lights. But with Mars, since it doesn't have an atmosphere, what happens is that the solar wind sheds off the atmosphere of Mars. So if you travel in time, you can keep going further. Eventually, Mars will lose most of its atmosphere. And another part of evidence that we know of this is that we can actually see auroras happen all around the planet Mars. Now, these auroras are a lot different than the auroras found on Earth. These are ultraviolet auroras. You wouldn't actually be able to see these auroras with your eyes. You would have to look in the ultraviolet light. But what's happening is the solar particles, particularly what we call alpha particles or protons, are hitting the upper atmosphere of Mars and are stripping away layers of the Martian atmosphere. So over time, Mars is slowly losing its atmosphere. And as I said, if you fast forward billions of years of time, think about a sandpaper. You keep sanding something down over and over again. It's going to get thinner and thinner and thinner and thinner. And now we have the Mars today. It lost a lot of its atmosphere. It can't hold a lot of the water vapor in the atmosphere anymore. It doesn't retain heat, so it cools down. And so that's how we end up with the Mars that we have today. So what I'm going to do now is I'm going to switch back over to Uniview here. And we're going to go ahead and take a look at some other interesting features on the Martian surface. So now that we have the Mars today, let's take a look at some of the interesting things that we can see with Mars. So what I'm going to do here is we're kind of looking in an area of Mars that's not what I would like to share with you all here. What we're going to do is we're going to take a look at an area of Mars that's very geologically interesting to me. And it tells us the story of an ancient Mars that was once different than it is today. The first feature I want to share with you all is this big giant rift called the Valles Marineris. And no, it's not made out of marinara sauce. It's a large rift valley, most likely a separation between two continental plates a long time ago when Mars was active. See, Mars doesn't have plate tectonics like Earth has. That's the movements of the continents on Earth anymore. But a long time ago, Mars, because it had an active core, things were moving around. And we think that this was a separation of two of those plates a long time ago. And what we're going to do now is we're going to go ahead and zoom in even more. And you'll see here, we have this large canyon. This canyon stretches the length of the United States. So you could travel from New York City to San Francisco all throughout this entire large canyon. And these walls here, these cliff walls are taller than the tallest mountain on Earth, Mount Everest. So these are some big, 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 big walls. But if we come over here to the other side of the Valles Marineris, we can see this area known as the Noctis Labyrinthus. Now, I'm sure all of you know the largest canyon on Earth, right? Yeah, that of course is the Grand Canyon, yeah. And the Grand Canyon is carved out by the flow of the Colorado River. Well, a long time ago, as this valley was forming, the other part of Mars just above it, called the Tharsis Plateau, was getting lifted up. And glaciers and ice and snow eventually melted and flowed down into these areas like we see here, these canyons. And eventually, this water pooled in and slowly carved out these various layers of rock until eventually it dumped into the Valles Marineris. So a long time ago, we think that the Valles Marineris was covered in water, and some of that water got splashed in here, creating these what we call alluvial fans here, or basically erosion. So as you can see here, we have lots and lots of evidence of a very different type planet than we have today. But speaking of the Tharsis Plateau, when things get lifted and moved around, sometimes you get volcanic eruptions. And in fact, actually, there are several large shield volcanoes. These are volcanoes very similar to what you see in Hawaii, formed on the surface of Mars. These are called the Tharsis volcanoes. Arceus Mons, Ascraeus Mons, and Pavonis Mons. These are the 3 large volcanoes found here in the Tharsis region. But to be honest with you, these are dwarfed compared to the largest mountain or the largest volcano in the solar system. That is called Olympus Mons. Yes, Olympus Mons. We're going to go ahead and zoom in on Olympus Mons so we can take a look at this behemoth of a mountain here. And just to give you all an idea of the sheer size of this large geological feature, what I'm going to do here is I'm actually going to see if I can, I can trace on here. And I am not a great drawer, okay? So please, please, please give me some credit. But what I'm going to do here is I'm going to go ahead and draw the state of Florida. So I'll start here with the panhandle. All right, so I'm going to start drawing the panhandle. And there's kind of near Jacksonville. And there's the bottom there. Again, really, please bear with me here on the drawing. But this gives you an idea of just how big Olympus Mons is. You can fit the state of Florida inside Olympus Mons. And this area here where the caldera is, basically that's where all the lava would have been spewing out, would have been as big as all of Central Florida. So you could travel from, Daytona Beach all the way down to Tampa in the distance of this large caldera there. So this is a very large mountain. Now, how tall is this mountain? Well, remember, as I said, the tallest mountain on Earth is Mount Everest. You could stack 3 Mount Everests on top of each other to get to the height of this volcano. This, again, is also the tallest volcano in the entire solar system. So this is a very large object to look at on the red planet. Now, we're going to go ahead and zoom out here. I want to talk about some other features on the Martian surface. One of them is actually we're going to go to the southern ice cap because we're in the summertime on Mars. We're going to go ahead and, in the southern hemisphere, that is. We're going to go over here down here towards the pole. Now, both the northern and southern pole of Mars have ice caps. And 70% of those ice caps are made up of water. But on top of that is a little thin layer of frozen carbon dioxide called dry ice. And over the summer, that dry ice can actually vaporize off the ice cap and then eventually form frozen carbon dioxide clouds. Sometimes it gets so violent that the pressure of that carbon dioxide basically explodes areas of the ice cap and creates these giant carbon dioxide geysers that shoot off, which is really, really cool. And then in the wintertime, when the carbon dioxide in the atmosphere freezes, it actually snows dry ice, and eventually it then falls down to the surface where we have the polar ice cap. So there's this kind of cycle between cooling, vaporizing, cooling down, snowing, and that kind of thing there. So it's a pretty neat little thing there. So again, this is also happening on the northern ice cap as well. There we go. Oh, I think did we lose it? Are you guys seeing it still?
We're still on the southern pole.
Okay, I'm gonna stop sharing. Uh-oh. Do we have an error here? Uh-oh. Are we frozen?
Would be appropriate.
Oh, there we go. All right. Yeah. Hey, you know what? It is. If we were going to do this live, it would happen anyway. So, it is what it is. All right, we're going to try this again. Oh, I think that's because I got kicked off. Interesting. All right. Well, you know what? That was pretty much. Let me see if I can go ahead and log in again. I'm not sure why why I did that. Let me try this again here. All right, gotta love technology, right? Let me see if I can open. Let me see if I can get back on Zoom here. All right, it looks like I am back on Zoom. All right. Great. Okay, let me see if I can make myself co-host again so I can share. All right, here we go. All right, we're going back on to Mars. Okay, are we? All right, here we go. Yay, we're back on Mars again. All right, so again, what I wanted to show you all here is the northern ice cap. It's kind of hard to see right now because it's in the nighttime, but you can see just how much bigger the north ice cap is compared to the southern ice cap. So pretty neat. Now, one of the things I wanted to talk about as well is that there's currently a mission on Mars, and it's a little guy here called Curiosity. So what we're going to do is we're going to go ahead and visit Curiosity. Oh, there he is. Look at him. Everybody, wave hello to Curiosity. Hey, Curiosity. And Curiosity is our current robotic mission on Mars. Its mission is to explore an area known as Gale Crater, and it's actually going all the way around this this crater, looking for different layers of the Martian surface to learn about the earliest parts of Mars. The area that Gale Crater, the area that's in Gale Crater, is one of the most exposed areas on Mars. So about 3.5 billion years worth of geological time is exposed in this area. So it's a lot of science that we can learn about this area here. Now, Curiosity itself is about the size of a school, or it's about a small car. So just to give you an idea of how big our little rover is. And that rover is nuclear powered. Yes, it doesn't use solar. It uses radioisotopic thermogenerator. We also call that a RTG, and it actually creates the energy needed for this spacecraft. Now, this large mountain that we see in the back there, that's called Mount Sharp. You can see it back there. There's our beautiful Mount Sharp. That's kind of the area. And actually, Curiosity has kind of is now in that area looking out at Mount Sharp. But what I'm going to do here is I'm actually going to go ahead and show you all Gale Crater from space. But what I'm also going to do too is I need to turn on another layer. We have this feature here in UniView where we can add other layer sets. So I'm going to go ahead and do that now. We're going to upload a layer called the Themis map here. So let's go ahead and add that. And that will give us a little bit more resolution. Check that out. That looks much better, doesn't it? Yeah, this gives us much better resolution on the surface here. And we're going to go and zoom down. And essentially, just to give you all an idea of what Curiosity is doing, is Curiosity landed kind of in this area right here. And it is now traveled all the way up in this area over here. And just to give you an idea of how far Curiosity has traveled, it's only traveled about probably what, 15 miles or so? Is that around that range? What do you guys think? About how many miles? Does anybody know?
I think it's about 12.
12 miles, yeah. So I knew it was around that 15-mile range. And just to give you an idea, I mean, that's nothing. You know, people think that these rovers are traveling all around the red planet, but really they're only traveling just a couple of miles here. And just to give you an idea for those that live in Central Florida, that's like driving from downtown Orlando to Disney World. That's the length of travel that this rover has traveled. So again, not a whole lot of distance. So again, we haven't really explored the extent of the Martian surface that we have. So there's still a lot of the planet Mars that we don't really know about. Now, the last thing I want to talk about before I move it on to Ken with his little presentation is I want to show you all the moons of Mars. Yes, Mars has 2 moons. Now, when we think of our moon, it's fairly large, about a third the size of Earth. But both of these moons are really tiny. They're only about 32 miles put together. And for those that live in Central Florida, that's about the size of Seminole County in square mileage. So just to give you an idea how small these moons are. And this is the largest one. This is Phobos here. So look how tiny little Phobos is. It looks kind of like a baked potato or potato. I don't know. What do you think? Which one do you normally say? Potato, Ken? What do you?
Potato.
There we go. Potato. Thank you. Okay. This moon here again is really tiny, and we think both of these little moons were captured asteroids. The asteroid field is not too far away from Mars, so believe it or not, it's pretty realistic to think that Mars captured some of these asteroids as they were being flung into the inner solar system. So that's Deimos, and this one here is that was Phobos. This is Deimos, and Deimos is very tiny, only about 6 miles in size. And just to give you an idea, if you like basketball, you couldn't really play basketball on Deimos because literally if you were to jump up in the air, you would literally fly off into space. So definitely you would not want to go on Deimos if you want to play a game of basketball. Or Super Mario wouldn't have a very good time jumping up to get those bricks if he was on Deimos. So bad day for Super Mario as well. But again, these are little captured asteroids, tiny little moons. And, actually both of them are actually being pulled gravitationally by Mars. So actually slowly but surely these moons will eventually be succumbed to an impact with the planet Mars. All right, so what I'm going to do now is I'm going to turn off the share here, and I'm going to turn it over to Ken, because he has a really cool presentation that's going to talk a little about some of the missions that have visited Mars and are going to visit Mars pretty soon. So Ken, I'm going to let you take up the next part.
So here, there we go. Now I'm unmuted. And we'll start our slideshow from the start. The Mars Perseverance mission is the next great mission to Mars. It's being launched this July or August by NASA, and we'll be going to a place on Mars called Cirillo Crater. We'll talk more than that about that in a minute, but we want to talk first about the history of exploring Mars. And just like Derek showed us a minute ago, there's the Valles Marineris and the Tharsis plain, and the volcanoes off in the left-hand margin there. And this is from a global mosaic taken by the Viking orbiters back in from 1976 to 1981. Now this is what Mars looks like in a pretty decent telescope from Earth. Like this might be the view Derek might have of Mars when it gets pretty close to us. You can barely make out ice caps in the north, and actually the North Pole down here and the South Pole up here, because it's an inverted image, I think. And there's Syrtis Major right there, one of the larger surface features on Mars. This is Mariner 9. Mariner 9 launched or arrived at Mars in 1971. And Mariner 9 did a really incredible thing. When it arrived at Mars, Mars was having a global dust storm. So basically, the only thing you could see was the tops of the volcanoes. That was it. Everything else was obscured by dust. So JPL, the Jet Propulsion Lab, wisely put Mariner 9 to sleep for about 6 months to wait out the storm. The storm settled down. All the surface features of Mars became visible again. And they woke the cameras back up and started sending data back. Now another probe, a Soviet probe, I can't remember its name, I think it might have been Mars 5 or something like that, was also sent to Mars at this time, but unfortunately they did not have the technical capability of putting the rover to sleep. So the Soviets got a lot of pictures of dust. Bravo. Well done. But we actually got pictures that really showed Mars to be an active geological world in the past, and definitely worthy of more study. Because of the success of Mariner 9, NASA launched 2 more spacecraft called the Vikings 1 and 2. The Vikings 1 and 2 featured a lander and an orbiter, and both orbiters lasted at least 5 years, which is about 4 years longer than they were supposed to last. So you're going to notice a trend here in robotic exploration. When JPL builds it, it lasts for a really long time. Okay, so there's the Viking orbiter and lander. The lander's at the top here, this little balloon-shaped thing. That's going to be the lander. It's the shell protecting it from deep space and from Mars when it first arrives. And this is the Viking lander. I think this is Viking 2, scooping up a shovelful of dirt from here back in 1976. Landed right around July 20th of 1976. So this is the Sojourner rover, along with the Pathfinder mission. Pathfinder's actually taken this picture of Sojourner bumping up to a rock named Yogi. Whoops. And Sojourner was the test of, can you actually drive a rover on Mars? Can a rover actually navigate rough terrain and find places of interest that you want it to go to? So the rover Spirit and Opportunity continued that mission. Spirit and Opportunity were wildly successful. Spirit lasted until 2011, which is about 20 times longer than it was supposed to last. And Opportunity lasted an incredible 54 times longer than its stated lifetime. The engineers, when they packed it up and sent it off to Mars, said, we give this thing 90 days. And it ended up lasting almost 15 years, the Opportunity rover did. So they took incredible pictures of Mars. You still can go to the Opportunity website and download any of the 276,000 images this thing took of Mars. Now, the lander nobody's ever heard of is Phoenix. Phoenix landed in 2008 near the North Pole of Mars, up in the north of the Martian Arctic Circle. And on 3 different dates, and you can see Sol 8, Sol 31, Sol 44 here, it got droplets of briny salt water that Derek was talking about earlier on one of the legs of the lander. So we actually have some evidence for liquid water currently extant on the surface of Mars. Now, in order to stay liquid at those temperatures and pressures, really low pressure, really low temperature, it has to be very, very salty. And this is indeed very salty water that was on Mars. This is the Curiosity rover, and Derek's already told you about Gale Crater and Mount Sharp. This is a selfie taken by the rover. It basically extended out its robot arm and then turned the arm around to look back at the rover with the camera. So you've got several pictures of Curiosity in its native habitat. Now remember this body plan, because this is the same basic body plan for the Perseverance rover. Now, we should talk about the long-term architecture of NASA's missions to Mars. Starting from the beginning of the millennium here, we have the Mars Odyssey and all these other orbiters, some of which were launched or will be launched by different nations. For example, in the year 2020, or this year, the HOPE orbiter will be launched by the United Arab Emirates. So that'll be, I think, the 4th country that's trying to send something to Mars. Of course, the Mars 2020 rover is launching in 2020. And soon we'll have sample return missions, and we'll talk more about that in a minute. This is the Mars 2020 rover, fully decked out, nuclear power back here in the aft end of the rover. One of the antennas here, the robot arm, which extends about 8 feet out in front of the robot. It's got drills and other things on it. The second coolest instrument on this rover is the laser, which shoots laser beams up to 30 feet away, and it can actually dissolve the top centimeter or so of rock. If you aim it like 600 times in the same place, it'll actually burn off about a centimeter of rock. What that does for you is it gets you underneath this rust crust. Remember, Derek was talking about iron oxide. Well, that's everywhere. And so we know what the surface of Mars is made of, but what about the rocks underneath the surface? What are they made of? And that's what all the rovers from Opportunity on out have been able to answer those questions, because they've all had some kind of instrument to drill underneath, whether it be a drill, as in Curiosity in 2020, or a wire brush in the case of Opportunity. So in order to get to Mars, of course, you have to launch from Earth. And of course, most of you are familiar with the scene here, Cape Canaveral in Florida. That's where 2020 will be launching starting July 17th, running all the way through the beginning of August. So it can launch on any good day in that 3-week, what's called a launch window. Then, of course, we have to spend 7 months cruising to Mars. And you'll see in this image here, there's the robot beginning to enter Mars's atmosphere. Then, of course, once it's gotten through with the parachute and everything else, we have entry, descent, and landing. The same scheme that Curiosity used back in 2012 is being used by the Perseverance rover, being landed down from a sky crane. Soft landing on the surface on its wheels. And then, of course, the actual surface ops. This is Curiosity manipulating its robot arm. And what is Mars 2020 actually looking for? Well, Mars 2020 is looking for organics. It's looking for organic molecules in the rocks. It's looking for biosignatures, astrobiology here, looking for actual fossils left in the rock. And where it's going, these are some of the instruments aboard Perseverance, which are going to do that. This is a stromatolite fossil from Australia here on Earth. And Mars 2020 will be able to recognize features like this using several of its different instruments. And there are two instruments I'm going to talk about with this slide. One of them is the sample cache regime. There's an entire subsystem in the rover designed to carry up to 42 samples. And what it's going to do is take samples from different places in Jezero crater and cache them, store them, and then drop the package off in some location to be determined, probably somewhere quite easy for another robot to go pick up the package and bring it back to Earth. NASA is tentatively slating that mission for 2024. And you're noticing a pattern. Hopefully you're noticing a pattern. We can only go to Mars every 2 years. As I showed you the video earlier, when Mars and Earth are getting next to each other in space relative to the sun, that's when we launch to Mars because it's the most fuel efficient. These are the sampling tubes themselves, and your pinky is a rough idea for how big one of these sample tubes are. So if you were to hollow out your pinky and put dirt in there, don't actually do that at home, please, thank you. That would be about the amount of soil and rock and minerals that will be launched back to Earth in the sample cache things. The other instruments that's on here that's not pictured is something that Justin's going to talk about in a few minutes in the human exploration of Mars. This experiment is designed to take carbon dioxide from the Martian atmosphere and convert it directly into oxygen. And this is a technology test to see if that will actually work. Now, this is where, if you look at the global map of Mars, this is an altimeter map. So the different colors represent altitudes. The purples and blues are below what's called mean sea level. Greens would be right on the shoreline of an ancient sea, should one exist. And yellows, oranges, and reds, browns, and whites are higher terrain, the whites being the highest terrain, like the volcanoes here. So we're going to zoom in on Jezero crater, get a little bit closer to it. And when you get up close to Jezero crater and you look at it through a spectrometer, what you see are different rock layers. You also see a river valley running through here, which empties out into a delta. So here used to be an ancient lake. Now Perseverance is going to land somewhere out here in these plains west of the delta and then drive into the delta itself. Several different schemes are being modeled for that drive. But basically they want Perseverance to drive all the way up through the delta, up and over this rim of this crater, and over to another region on Mars called Southeast Syrtis, which has a lot of other mineral signatures that they want to look at. So they're trying to get 2 landing sites out of 1. So they're hoping that Perseverance lasts longer than its advertised 2-year Martian lifetime. So that's the plan. And of course, landing on Mars is going to be a little bit different. There we go. Perseverance's landing ellipse, that is the region where it could land, is much, much smaller than previous missions like Curiosity's landing ellipse. Phoenix and Insight had a much, much larger landing ellipse, and Mars Pathfinder was huge compared to this. The point is, we couldn't explore Jezero crater if we had to deal with a landing ellipse and technology back in 2012. Jezero crater was considered as a landing site back when they were selecting landing sites for Curiosity back in 2010, but it was discarded because it wasn't safe enough. Gale crater was a lot safer region, that's why they landed there. So Mars 2020 has a better landing technique. It can actually use radar. Compare the radar to to images taken by what's called the high-rise camera on the Mars Reconnaissance Orbiter to surface images on board the computer aboard the rover. And the rover can sense, okay, the terrain is rough, I have to deviate. Terrain relative navigation is what it's called. And you can take if you're coming down in a bunch of hills and valleys that you're probably going to crash your rover in, the rover can actually do what Neil Armstrong did back in 1969 with the Eagle, and actually avoid rough terrain to land someplace nice and smooth, like the floor of the crater. Again, that landing ellipse, don't want to land here because that's a bunch of sand at the bottom of the crater. Don't want to land here because it's a bunch of bumpy hills and valleys. You want to land out here where it's nice and smooth. So as it's descending, it takes images of the terrain, matches them up with images that have been taken by an orbiter, Mars Reconnaissance Orbiter, and then figures out which is the smooth terrain to land in and uses that. Okay. Now, the entry, descent, and landing of this rover is going to be much, much better documented than any previous landing. Because number one, the JPL engineers want to know what landing on Mars really looks like and sounds like. So there's a camera on the back shell that's actually pointed up at the parachute. So when the parachute deploys, you can see, did the parachute deploy properly? How many seconds did it take? Did it go through any baffling or anything else the parachute does before it fully inflated? Another camera will be looking down at the sky crane assembly, looking down at the rover to make sure the sky crane is working properly. Now, all of these cameras have microphones on them, which means not only are you going to get to see it, but probably within a day or two after the landing, someone at JPL will put together the animation of all these cameras, set together and develop a really good image and idea for what it actually looked like if you could sit on the back of Perseverance while it was landing on Mars. Yeah, here we go. Okay, so the launch period, oh no, I'm sorry. This is a video of the coolest instrument on this entire rover. This is another technology demonstration. And this, I'll give you a hint, it flies. Spoiler alert. And my mouse is not doing what it's supposed to do. There we go. So the rover has come up on terrain it cannot transgress or cross. It's sending a scout. Radios the information back to the rover. But before we go to Mars, we have to test it on Earth. Pretty bad. Yeah, it's pretty bad. Up here we have solar panels to provide power for the battery on the rover, and the helicopter. This is the first time anybody's tried to launch a helicopter onto another planet. So this is pretty cool to hear. So the launch period opens July 17th of 2020, and it lands February 18th, a very discrete landing date, February 18th, 2021. Put it in your calendar at about 3 p.m. local time or Eastern time. So you'll be able to plan launch parties and other things and landing parties for this thing when it lands on Mars. And you'll be able to follow along, of course, at nasa.gov. So stay tuned because more is yet to follow. And that's the end of my presentation.
All right, thank you, Ken, for that. It was awesome. I'm really excited about Perseverance. I know I'm sure you all are too, especially that helicopter. I think it's gonna be really cool. I'm going to be really jealous of the person who gets to operate that, right? So what we're going to do now is we're going to shift gears, and we've been talking about geology of Mars, scientific missions of Mars, all that. But in reality, the hope is that in the future, some of us here on Earth are going to Mars. And Justin is kind of our expert in space exploration at the planetarium, and he has a passion for it. And what he's going to do right now is he's going to go ahead and start up a presentation all about our future exploration of Mars. And so what do we have in store for us, Justin?
Okay, well, yeah, the thing is, Derek, everyone wants to go to Mars. NASA wants to go to Mars. SpaceX wants to go to Mars. Why does everyone want to go to Mars so much? Well, if you think about our solar system, you think about how lucky we are to have a planet like Earth, such a wonderful place, perfect environment for us to live and enjoy things, except for right now, but we'll get past that. If we ever want to live anywhere else besides Earth, there's not a lot of options. Mars is our best option. Mercury, way too hot. Venus, it's even hotter than Mercury. We can't go to Jupiter, we can't go to Saturn. Those are gas giants, and it's way too cold out on Uranus and Neptune. So if human beings ever want to be a multi-planet species, Mars is our only option. And so we're going to talk a little bit about what we are doing to put human boots on Mars. Okay, here we go. Artemis is NASA's project to put humans back on the moon. Now, if you want to go to Mars, you probably need to practice somewhere besides going to Mars first. And we've done a very good job of putting robots on Mars. You've seen that in Ken's presentation. You saw in Derek's presentation. We know the geology well. We know the surface well. We built these fantastic machines like InSight. We've mapped it to so much detail. But to put humans there, we're not robots. We're a lot more complicated. We're a lot more needy, and we're harder to keep alive than robots are. So if you're going to put human beings on the moon, you probably want to practice somewhere first. And if you want to put humans on Mars, you want to practice on the moon. And that's exactly what Artemis is. Artemis is the twin sister of Apollo. And if you remember the Apollo moon landings back in the 60s, this is the next generation project to do that. And you can see here in the image, we've got in the upper right-hand corner, the Orion crew capsule. This will be what takes those astronauts from Earth to the moon. It arrived recently in Florida from a testing station in Ohio, where it went through a series of temperature tests. This station is able to create the same vacuum as space. And so the Orion capsule went through those series of tests and was delivered in this funky looking plane called a Super Guppy, this giant propeller driven aircraft that brought it back here to Florida. Now, what is going to put Orion up into space? We're going to talk about that here in a minute, but Artemis is pretty exciting, and what this is going to do is going to be over the next 4 years, NASA working diligently to put human beings on the moon. Now, how do you do that? Well, you do it in stages. Stage 1 is a uncrewed test around the moon and back, and this is going to happen hopefully in 2021. If that happens well, all goes to plan, then in 2023 would be a crewed mission around the moon. We haven't landed on the moon yet. We're still just orbiting around it, coming back to Earth in 2023. And then if all that goes well, we're looking at a 2024 landing on the moon. And why do we want to go back to the moon? I mean, we were there 50 years ago. We we did some science experiments, we grabbed some rocks, we brought them back to Earth. Well, we did a lot of amazing science and we accomplished a lot of amazing things, but we found something recently that changed the game, and that was water, an abundance of water. Now, NASA had done multiple tests where they actually sent projectiles down to the moon and studied the debris that came up from those impacts and saw that there was water below the surface. But the Lunar Reconnaissance Orbiter that's been mapping, detailed mapping the moon over the years, found in abundance in the poles, particularly the southern pole of the moon, glaciers, frozen glaciers of water that were probably brought billions of years ago by a comet or an asteroid that crashed into those southern parts of the moon, deep in craters that are in perpetual darkness, that never really see the heat or light of the sun, and have remained frozen there for a long time. So this completely changed the game. With water now on the moon, we're able to do a couple things that we couldn't do before. Produce rocket fuel. Water is H2O, as we know, and rocket fuel is liquid oxygen and liquid hydrogen. So by traveling back to the moon, now we can refuel, use the moon as a gateway to travel to other areas of the solar system. Now, we've had the technology to go to Mars for a long time. Here you're seeing a picture from 1969. This is the Saturn V rocket. This is the rocket of the Apollo program that traveled to the moon multiple times. And we had 6 landings on the moon. 7 we tried with Apollo 13, didn't make it. They had to slingshot around the moon and come home. And then Skylab, which was kind of the first iteration of the International Space Station before that existed. Well, this rocket was designed by Wernher von Braun, and this rocket scientist is really the one responsible for creating this beautiful machine. And his vision was to always go to Mars. Yes, we wanted to go to the moon, and he was on board for that, but he built this rocket in the back of his mind to then go to Mars. What changed the game there was really, it came down to funding, and that's a lot of what happens with space science and space. We're talking about expensive projects, and after Apollo 17, Congress and the president decided that was a little bit too expensive for what we wanted to do, and things kind of died down there before the shuttle program started. So we've had the technology for a long time. This rocket was built to go to the moon, but it was also capable for deep space. Well, it's been a long time, and we have obviously made a lot of improvements in our rocketry and rocket systems, and that takes us to now the present, which is the Space Launch System. The Orion crew capsule that you saw earlier in the slide will sit atop this rocket, and this will be the largest rocket ever built to take humans into deep space. So pretty exciting. The rocket is complete. It is undergoing a battery of tests, and unfortunately, in the environment that we're in right now, coronavirus has put a pause on a lot of that testing. So the timeline for Artemis could be affected by what's going on in the world today, but obviously that is much more important to keep our engineers and scientists safe until we can get back on track and keep this mission going. But until then, we'll wait and see where that takes us. In the meantime, NASA is not the only company that wants to go to Mars. You've probably heard of a company called SpaceX. And SpaceX has done some amazing things over the past 5-10 years, and we've seen them come up from just a kind of small commercial rocket company to now the pioneer, where they're really competing with big companies like Boeing for these massive NASA contracts. Well, SpaceX did something that was really important for us to go to Mars, is they created reusability in rocketry. Think about if you wanted to get on a plane and fly to Europe, and after you were done with that flight, they threw the plane away. Well, that's how rockets have been for many, many years. SpaceX changed the game where now you can reuse most of that rocket and bring the cost down incredibly much more lower and affordable, because it's expensive to lift supplies and lift human beings up into space. By creating reusable rockets, we've now made it much more feasible to go to the moon easier and eventually go to Mars. This May, mark your calendars. We don't have an exact date yet, but it's a pretty historic launch coming up. 2011 was the last time American astronauts left American soil to go up into space. Now, Americans have been flying into space nonstop since the Apollo program. Actually, there was a launch today from Kazakhstan. 3 astronauts, one of them was an American. They left today, this morning, about 4 a.m. Local time, to go up to the International Space Station. But it hasn't been since 2011, when the shuttle program ended, that we've seen American astronauts fly into space from American soil. Well, all that is going to change in May, and this flight is still, this launch is still on schedule. This is NASA astronauts Doug Hurley and Bob Behnken, and they will be the first ones to fly on SpaceX Crew Dragon spaceship. And this is a Falcon 9 rocket with a modified Dragon crew capsule that will allow these astronauts to launch here from Florida, dock with the International Space Station, and then safely return home. If this works well, then there will be one more demo with 2 other astronauts before this becomes a regular occurrence. Now, there's 2 things about this flight that is very special. One, again, it's been 9-10 years since Americans have left Florida in a rocket. But 2, this will be the first time ever that astronauts have gone into space on a commercial rocket. Prior to that, it's all been government-run programs. So just a very exciting, you do not want to miss this launch. If you're local in Florida, I'm sure the Cape is going to be packed as far as the eye can see with people. So wish these guys luck on their launch next month. Derek and I were lucky enough to receive press credentials for this launch, so we will be there with our cameras ready to record as much as possible and report that back to you. So this is the early stages for SpaceX. They have bigger aspirations, though. One, yes, they want to put Americans up into the International Space Station. 2, they want to go to the moon also. 3, they also want to go to Mars. And they're, you could say, kind of in a little bit of a race with NASA to maybe be the first ones to do that. This rocket that you're looking at here is called Starship. And just to kind of, if you look closely down to the left of this rocket, you can see 3 men there, probably engineers as part of these demos. But look how big this rocket is. On the right-hand side, you can see a Falcon 9, one of the early Falcon 9s in SpaceX rocket program. Look at the size of this rocket. This is a heavy lift vehicle, and this will allow SpaceX to deliver not only equipment to the moon and to Mars, but a lot of people. They don't want to just take 1 or 2 people. They want to take maybe 100. Now, these are a lot of bold ideas, a lot of advanced theories of how we can do this. And we're finding out that it's tough. When we talk about going to Mars, you've probably seen, if you've been to Kennedy Space Center, there's Mars propaganda everywhere. And that's the goal, right? The goal is to get there. But ladies and gentlemen, boys and girls, we're not close yet. We've still got a long ways to go. Space is hard. And SpaceX is finding that out right now as we speak. This is a couple images of Starship going through some cryogenic pressure testing. And as you can see, it didn't go well. Now, there were no one on board these tests, so all that was damaged was the fuselage. But you know, getting into space is hard. Getting back to the moon is even harder. And just think about the distance it would take to get to Mars. The moon is 238,000 miles away from Earth, and that's the farthest human beings have ever been from our planet. But we're talking about millions and millions of miles further to go to Mars, and that completely changes the game. Human beings weren't really designed to be in space for very long, and we found that out in experiments with astronauts who have spent a lot of time on the International Space Station. Being in microgravity for long periods of time, it affects our biology. It affects our bones. It affects our muscles. It affects even your eye. Everything in our bodies was designed for gravity. And with that lack of gravity, problems can arise. Again, we're not robots. And so all of this extra care has to take place in order to take us not only to the moon, but way out into Mars. Now, one of the most common questions I get when we do outreach and we do shows at the planetarium is, you know, we went to the moon 50 years ago. What's NASA been working on, you know, all this time? What's been going on out there? And if you don't see it in the news, you kind of have to go look for it. It's there, trust me, it's there, but there's a lot that's been happening. And one of the most amazing things that's been happening over the years is our ability to improve our science to the point now where we can land on an asteroid, take a sample of that asteroid, and bring that material back to Earth. What you're seeing here is OSIRIS-REx and asteroid Bennu. OSIRIS-REx is the name of the spacecraft that is currently orbiting asteroid Bennu right now as we speak. It actually arrived there in 2018 and has been orbiting around this asteroid, taking detailed mapping of its surface. What's going to happen here is OSIRIS-REx is going to land on this asteroid, take a sample of the regolith, and bring it back to Earth. So that's one of the things I like to tell people when they say, what's NASA been working on in the last 50 years? Think about the science to make this happen. These are the things that scientists have been working on, physicists, propulsion, the instruments that are on these machines, a lot of those things that Ken was talking about that was on Perseverance, the helicopter, the drills. Even though we haven't actively been sending human beings back out into places like the moon, boy, space science has been busy. And this is just one example of how far we've come in space technology. The sample site that OSIRIS-REx is targeting is Nightingale, and that's the image there that you see on the left. Excuse me, Osprey will be the backup site. Well, how is this going to happen? OSIRIS-REx is orbiting around Bennu now. Later this month, April 24th, will be the first planned rehearsal of OSIRIS-REx traveling down to the surface of the asteroid and preparing to tag the surface, collect that regolith, and bring it back out into an orbit before it sends it back to Earth. Well, how is it going to do that? There's an arm on OSIRIS-REx called the TAG-SAM, and very quickly it's going to touch down onto the surface. It's going to blast nitrogen down through these pipes, pull up that regolith, collect it in those side containers, and all of this will come back to Earth in 2023, scheduled to land in the Utah desert and be collected for us to study further. And just like Ken Brandt had mentioned about how Perseverance is collecting samples to be brought back to Earth, this tells us a lot more about these surfaces than we could ever get by just studying it from a robot. So when we get to Mars, what's it going to look like? Well, here is an artist rendition from SpaceX of a Martian colony. Now, again, we're talking way out in the future here. A landing of putting human boots on Mars might not even launch until 2030 or somewhere in that decade. So we're looking, based on what you see here, much further out, where you can see farming, you can see situations where on Mars we have a lot of in situ resource utilization that we have to do. And what does that mean? Well, it's very expensive to take supplies to Mars. If we can utilize what's on Mars, the water that was talked about earlier, converting that CO2 into oxygen, we've found that only 14 plants on Earth can be grown on Mars. So we have to re-engineer the soil on Mars in order to give us the farming that we need to put a colony there. Those critical elements like phosphorus and nitrogen into the regolith of Mars in order to farm properly. We probably will not spend a lot of time on the surface, though. When you heard Derek talk about the atmosphere of Mars, when you heard Ken talk about the atmosphere of Mars, it doesn't offer the same protection that Earth's atmosphere provides us here. You wouldn't probably be able to spend much time on the surface because that atmosphere is so thin. Our cells would be exposed to much more solar radiation than they can probably handle. So this might be a little bit more of a realistic scenario of what we'd be looking at. In the bottom right-hand corner of your screen, you can see what's called a lava tube. And this is from the early formation of Mars. And these are kind of cave-like conduits below the surface, and they're in abundance. This is also where we're finding these underground glaciers. Down here below the surface, we'd be much safer from the sun. We'd be able to harvest that water that we need, not only for humans, but to give us rocket fuel for return trips back to Earth, and to engineer the soil that we need to do the farming that would also probably need to be underground, protected from solar radiation. So to kind of recap, before we get to Mars, we want to practice all of this on the moon. NASA wants to get human beings back to the moon. If we can get back to the moon, we can do all the necessary science to prepare us for that long journey to Mars. SpaceX wants to get back to the moon so that they can test a lot of their equipment and then make that big jump out to Mars in the long term. So we've still got a long way to go, but it's a very exciting time right now to be alive, to be able to watch this technology being developed. And hopefully, if all goes well, many of us didn't get to see the original Apollo moon landings. 500 million people were able to watch that live in 1969, 50 years ago. I'm hoping that in maybe 10 years, maybe less, we'll get to see that again. Thank you. I'll pass it back over to Derek.
All right. Thank you, Justin. Really appreciate that. So Unfortunately, we would normally have question and answer time, but unfortunately we had an issue with Zoom. Hopefully that will be resolved. The connection between Zoom and Facebook, hopefully that will be resolved for our future events. But the nice thing is that there are redundancies. We are able to record this for you. So hopefully you enjoyed this presentation tonight. And again, you're more than welcome. If you have any questions, leave those either in the comment section below on YouTube or on our Facebook. We'll be sharing the YouTube link to our Facebook and to our Facebook event page. So that way everybody will know that we have that going on. But with that, I want to thank Ken. Thank you very much, Ken, for your time tonight and to join us on our virtual public show. And it's so cool to be able to work together on these kind of events. Normally we'd be running our planetariums and our shows and things like that. So it's nice to be able to collaborate on these, and we really appreciate your time. So we want to let you know about what's coming up next week. Of course, this is for YouTube forever. So if you're watching this on YouTube 2 years from now, this isn't going to apply to you. But for those that are watching it, in the next couple of days when this is uploaded, we are going to be doing another virtual public show next Thursday at 7 p.m. And we're going to be exploring the entire solar system. And we have another guest appearance as well. And we'll announce that later on. But again, thank you much. Thank you all, everybody, for coming out and joining us and spending some time with us here and enjoying this virtual program. If you like more and you like this, be sure to subscribe to us also on YouTube, because we'll be creating all kinds of exclusive content for YouTube in the next couple of weeks or so, in the next couple of months. So we'd love to see you support us and all that. What we're going to do now is that we're going to go ahead and end our program, and we hope to see you all again. And with that, be sure to keep looking up, clear skies, and we'll see you all next time. Take care, everybody. All right.
Bye-bye.
Everyone. Bye-bye.